Welcome to the video lecture Digital Principles and System Design. In this video lecture we are going to see the topics state diagram, state table and state equation under 4th unit synchronous sequential circuits design. Myself Samda Pratima, Assistant Professor EC Department, RMK Group of Institutions. These are the 4th unit topics: design of clocked sequential circuits, Moore and Mealy models, state minimization, state assignment, and then finally circuit implementation. Before going to see the actual topics of 4th unit, we must understand what is state diagram, how it looks like, state table, state equation and Moore model, Mealy model. For that, in this video lecture I am going to explain those topics. Let us see state diagram. A state diagram is nothing but it is a graphical representation of a state table. It gives the pictorial representation of behavior of the circuit. So here a very well known JK flip-flop excitation table I have considered. This is JK flip-flop excitation table. Here Qn is present state, Qn plus 1 is corresponding next state, JK are the flip-flop inputs, two inputs. So for present state 0, next state 0, then inputs must be 0, don't care. So here this is graphical representation of excitation table of JK flip-flop. Present state S0 is present state, state 0, and for flip-flop inputs 0, don't care. These are the flip-flop inputs. It is going to, that is, it remains in same state. So this is representing the first row. Then second row, present state is 0, that is S0, next state is 1, that is S1. So for 1 don't care where it is going to S1. For 1 don't care. For state 1 it is going to state 0, for don't care 1. So here it must be don't care 1, don't care 1. It is going to state 0. This is corresponding to third row. Now present state is 1, that is S1. Next state is also same state, that is S1. So for flip-flop inputs 0, don't care. So for 0, don't care, it is going to, that is, it remains in same state. Don't care 0. So don't care 0, not 0. Not 0 don't care, it is actually don't care 0. So like this we will plot state diagram from the given state table. Here there are two states 0 and 1. So possibilities 0 or 1. For example 4 states that is 0 0 0 1 1 0 1 1. So then 4 states will be possible. One flip flop means 2 states. Combination of 2 flip flop means 4 states. So here the circle represent coming to the circle represent state. Here S0, within the circle it is there, so it is called as state. S1 is also represented by a circle, so state is represented by a circle, and then the directed lines will give the originate, that is present state. The originate of directed line is the present state. This is present state of this arrow, and for this arrow the next state is S1 for this arrow. Then for this arrow present state is S1, and next state, this arrow ends here, so next state is S0 for this present state S1, and the input flip-flop inputs don't care 1. So like that we have to plot state diagram. And here this is called input, and if there is a slash some number, that is called output. So actually how it will be represented means a present state will be there, present state, and next state for that present state, and a directed line will be like this. A directed line is denoted having some input x cross y, so slash y. This x is present state, the x is input and slash y is corresponding output. So input slash output. This is present state, this is next state for this combination of input and producing output, corresponding output. Now this is one more example for state diagram. So as I told you, it is gives graphical representation for sequential circuits behavior, and here number of states are 4 states: 0 0 0 1 1 0 and 1 1. 4 circles will be there to represent 4 states, and here 0 slash 0 representing input is 0 slash corresponding output also 0. So here input is 0 slash 1 means corresponding output is 1. So for this arrow, this is present state. For this arrow, this is present state, and this is next state, and these are the this is next state, and these are the input and corresponding output. Next, I hope you understood what is state diagram. Next, this is present state definition and next state definition. So, and corresponding input slash output. For example, here next state is different. So, we have taken arrow like this. In some cases, if present state is 0 and next state also 0, that is it remains in same state, means then we will draw directed line like this, and corresponding inputs here. When the present state next state is same, then it will be looks like this. So what is present state means? It gives the information stored in the memory element at any given time, defines the present state of the sequential circuit. So at any time, what is the output of memory element? That is present state. And if we give external inputs to the circuit, and it will go to the produce next outputs, so those outputs called as next state of the sequential circuits. So upon giving external inputs, it will goes to next state, that is called next state. So next, state equation. State equation is nothing but it is a algebraic equation expression that specifies next state as a function of a present state as well as input. So here I have taken a well-known equation for a JK flip-flop, characteristic equation. This is next state Qn plus 1, present state Qn present state, J and K are the flip-flop inputs. So next state in JK flip-flop is equal to present state and complement of present state and J plus, that is R, present state and complement of K. So this is the characteristic equation of JK flip-flop. If there is, we are using in a sequential circuit a JK flip-flop, then this will be state equation. So state equation will be gives the algebraic expression for next state in terms of present state, and flip-flop inputs. So next state as a function of present state and flip-flop inputs. Next, state table. So here I have taken the characteristic table of the JK flip-flop to better understand what is state table. State table consisting of 3 columns, here input, present state and output. So J0 K0, you know that for J0 K0 combination, the flip-flop will remains in same state. If it is already 0, it will remains in 0, it will 1, it remains in 1. So 0 1, same 0 1. Next, 0 1 combination. So since K is 1, K means reset, so it will go to reset state. J equal to 1, set state, so flip-flop go to 1, set state. K equal to J equal to 1 1, then what it takes the complement of the state. It is already, it is in 0, it will go to 1. If it is already 1, it will go to 0. That is the complement of the toggle, we can call it as toggle. So like this, the state table is a table represent the relationship between input, output and flip-flop states. Now Mealy model and Moore model, let us see. Mealy model. So Mealy model, this is the state diagram. Here there are 4 states A, B, C, D represented by 4 circles, and this directed line representing present state is A. For this input 0, it remains in same state A and producing output as 1. So here it is x/y. X is input, y is output. So Mealy model, the output will be explicitly written for each and every input, corresponding input, there will be corresponding output. For a directed line, the input output will be explicitly written. That is, the output will depends upon present state as well as input in Mealy model. Next, Moore model. In Moore circuit, output should not be written explicitly. Instead of it is written within the circle. That is, it depends only upon the present state. So in this state, the output is 0. In B state, output is 1. It won't depends upon input. For C state, if the circuit is in C state, then output must be 0. So here the output depends upon only the state, not the input. Input will decide whether it will stay in same state or it will go to next state, but it won't decide the output. Output depends upon present state only in Moore circuit. It won't depends upon input. So I hope you understood what is a state diagram, state table, state equation, Moore circuit, and Mealy model, present state and next state, output. So thank you.